Good evening, everyone. This is lecture number 13, which I think would be the last lecture in this category on ray optics, because we will be finishing ray optics with this short lecture on microscope and telescope. Now, remember, most of this microscope and telescope are theoretical subjects, which will be covered in more details in your board exam wala classes. Here, we are only concerned with those questions, those topics or those things that can come as question, and that requires us to remember some shortcuts, some formulae, and we are only concerned in about remembering those shortcuts and those formulas, and not how they are derived or how they are achieved. We're only going to see those formulae because those are the formulae that we are concerned about. So we will do this chapter in such a way that we get to know those formulas and we can utilize them in solving questions. Do we understand this, everyone? So we are not much concerned of the theory part. I will show you the diagram. You just have to note down the diagram. You just have to see what is the formula like and how we have to use it in the exam. Nothing all, because I don't expect a question from this part. If the question comes, it will be simple formula based, which the points that I give you will be good enough for you to solve them. So let us begin our quest for microscope and telescope. Microscope is of more importance to NEET students, because you will be using that microscope probably. And what is the simplest type of microscope that is possible? What is the simplest type of microscope that is possible? That is known as a simple microscope. I hope you understand what is a simple microscope. So the first heading is, my dear friends, a simple microscope.
Good evening, sir.
Good evening, beta. I can hear you. I hope I am audible and visible to all of you. Hello,
Yes, sir.
beta. Okay. So a simple microscope is what we are going to start our thing with. What is a simple microscope? A simple convex lens. A simple convex lens is your simple microscope. Do we understand this? Any simple microscope can be used to magnify objects. You must remember and understand that if the object is placed between the focus, and you can see here is the focus of this convex lens. If an object is placed between the focus and the optical center, we'll always get a virtual and an enlarged image for that object. That means what you have done is a smaller object now appears bigger to you. You have enlarged it, you have magnified it. That becomes a simple microscope. Whenever we are talking about microscopes or telescopes, what we are more concerned about is something known as a magnifying power. How big they can make us see things. Now, to understand the magnifying power of a microscope, or for that matter, a telescope, you have to understand some angles. Here is an angle that you can see. This angle, tan of this angle beta, and we are imagining that this angle is very small because microscope is used to see things which are very small. This tan of beta will be approximately equal to beta, and that, as you can see from the diagram, my dear friends, will be equal to h divided by minus u. This is h, the height, and u is the distance. So if you look from this right angle triangle, tan of beta will be h divided by minus u with the sign convention. Do we understand this? Yes or no? This is the first thing that you should remember, that this beta, this angle beta, is h divided by minus u. You can draw a simple diagram if you want to. You can draw this diagram, and just remember that this beta or tan of beta is h divided by minus u. Now, whenever we are trying to understand the magnifying power of an instrument, we must understand how big it is making the thing and compare it to how actually that thing was. So here we are comparing it with this beta with this angle alpha. This angle alpha is the angle where we normally look at that object, and what angle that object makes at our eye is that angle alpha. And this object, to see it properly, it must be placed at D. This D is known as least distance of distinct vision. Have you heard about this term? Least distance of distinct vision, yes or no? As doctors, you must be knowing this. This is the least distance of distinct vision, which for normal human beings is approximately around 25 centimeters. This point is also known as near point. To see a thing correctly, it must be at a distance of 25 centimeters from our eyes. Now, if I find the value of this alpha, which is approximately equal to tan of this alpha, that will be equal to this h, again this h, divided by this minus d. Why I'm writing it as minus d? Because it is with proper sign convention. Now, beta is the angle at which I see it with the help of this instrument. Alpha is the angle with which I see it without the help of this instrument. Therefore, the magnifying power MP, magnifying power of this simple microscope will be given by the assisted angle beta divided by the original angle alpha. How big it seems to how small it was. Do we understand this? If I divide both of these things, I will end up with this formula d by u. That is the only thing that you have to understand in this entire thing. Even if you don't understand what is alpha, what is beta, you just have to understand the magnifying power of a simple microscope is given by d by u. I'll give you 2 minutes to note this down. Note it down carefully. Let me know when you are done.
Sir.
Have you noted it down, beta?
Completed, sir.
Okay. If you noted this down, then remember, whenever we talk about the magnifying power of any optical instrument, microscope is an optical instrument, telescope is an optical instrument, we always find out this magnifying power in two cases. In case number one, image is formed at infinity. Infinity also we call it as far point. When the image is formed at infinity, which you can also call it as the far point. Do we understand this? Now, when this image is formed at the far point, the u, the distance of the object must be same as the focal length of the lens, then only the image will be formed at infinity. Therefore, in that case, the formula of magnifying power becomes d divided by f, because u becomes equal to f. Do we understand this? D is the least distance of distinct vision. Do we understand this?
Yes, sir.
To have the image formed at infinity, we must have the object placed at the focus. So d by u, which is the original formula, becomes equal to d by f. Do we understand this?
Yes, sir.
Now case number 2 occurs when image is formed at d. When I say d, it is the least distance of distinct vision. You can also call it the near point. In that case, what we do is that we put the value of d by ue from the lens formula. The lens formula is 1 by v minus 1 by u is equal to 1 by f. In place of v, I put minus d and then find the value of d by u. I'm not going to do all of that. I'm just going to write what the value of d by u will come as, and that will come as 1 by d by f. So that will be the formula if the image is formed at least distance of distinct vision. These are the two formulas that you will have to remember. Formula number 1 and formula number 2. The magnifying power. The magnifying power for a simple microscope when the image is formed at infinity and when the image is formed at the least distance of distinct vision. I'll give you 2 minutes to note this down.
That's sir.
Completed, sir.
Well done, sir. Then that takes us to the next heading, and instead of going forward, what I'll do is I will give you a question, and I hope that you can give me the answer to this question. And this question is pretty damn simple. And in both the cases, you have to find out the magnifying power. So the question goes like this. A thin convex lens of focal length 5 centimeter is used as a simple microscope by a person with normal near point 25 centimeters. What is the magnifying power of the microscope in both cases? Case number 1, image is formed at infinity. Case number 2, the image is formed at the near point. I'll give you 2 minutes to solve this question.
Sir,
Yes, beta?
sir, magnifying power at the near point is 6.
At near point is 6. Okay, what about far point?
At far point, it will be 5.
Very good. At far point, it is 5. Well done. At near point, it is going to come as 6. Let us wait for the other students to do it. Let us wait for 2 more minutes. Okay.
Yes, sir.
Everyone ends got this? Yes or no? No, yes. Shall I wait for you to solve this? Or shall I solve it? Do you want more time, bacha? Yes or no? No, yes. Or anyone got the answer? I'm still waiting. I got it. Aviram got the answer. Well done, Aviram. What about the others in the class? I have more students there in the class. Yes, beta?
Sir, solve it, sir.
Okay, you can't get it.
No,
Okay.
sir.
What is the problem? Can you tell me? What are you not able to understanding? What are you not able to understand here, bacha? If you can tell me, I can help you more probably. What you don't understand? You just have to put the formula. Do you know which formula to put? Do you know which formula to put? In both the cases, you just have to put this formula, beta.
Yes, sir, I know the formula.
Yes, so why can't you put that formula? What is the value of D given? Tell me. Is the value of D given to you? Yes or no? Put it. Okay, I'll do it to you. If you are finding it so difficult, there must be something that I don't get. Anyways, let us do it for the two cases. Case number 1, image formed at infinity. What is the formula, bacha, in this case for magnifying power? Tell me.
D by F.
Yes, just put the value of D by F. D is 25 divided by 5. What is the answer that you get?
5.
That is it. That is the answer. Was it so difficult? Was it so difficult? No, it was not.
Sir,
Yes, Peter.
I have used 1 plus D by F, sir.
That was for second case, bacha. When the image is formed at D.
Near point.
Yes. In that case, the formula is 1 plus D by F. In that case, the answer is 6. So in both the cases, answers are different, my dear friend. Bacha? Do we understand this? Yes or no? No, yes.
Yes, sir.
Everyone got this?
Yes, sir.
And I have raised
sir.
hands from everyone. So as I told you, these things are pretty simple and you will get a simple question like this. Don't get scared. The only thing is you will have to remember the formula that you are putting. If you don't remember that formula, well, then you might fall into trouble, because if you don't remember that formula, you will not be able to do anything over there. Do we understand this? Yes or no? No, yes.
Yes, sir.
Okay, so
Yes, sir.
that a simple microscope. This is the only question that I think that will come to your exam, in your exam. Anyways, we will do the other thing. And it's all about drawing that diagram correctly and understanding what is going on. So the next thing that we are going to do is what we know as compound microscope. Compound microscope. Do you know what the compound microscope is? Yes, bacha? Compound microscope. What is the difference between a simple microscope and a compound one? You will be using a lot more complicated stuff than the stuff that I am going to tell you. A compound microscope. Any idea what a compound microscope is? A simple compound microscope consists of two lenses. Do we know this? Yes or no? No, yes. You must have used it in the bio lab. Yes or no? Yes or no? So simple.
No biolab, sir.
No bio lab, sir, but you should know the things, sir. So I'll just mark out the important points and you will draw the diagram, sir. So it has two lenses, yes or no? An objective lens, this is the lens which is facing the object. You can see the object is here. This is a small lens, small aperture, small focal length. And then you have a bigger lens, eye lens. Your eye is here. The object is in front of the objective. It creates an image. This one is the image. Do we understand this? Yes or no? This image
Yes, sir.
acts as an object for the second lens. It is now between the focus and the center of the lens. So it will create an enlarged image of the same object, which will be virtual. Do we understand this? Yes or no?
Yes, sir.
What all things you have to remember here? One thing is this UO, distance of the object from the objective. FO, focal length of the objective. VO, distance of the first image from the objective. UE, distance of the object, no, distance of the first image from the eyepiece. VE, distance of the final image from the eyepiece. UE, distance of the first image from the eyepiece. This length that you see is known as the length of the microscope. Do you understand this total length? This is the length of the tube of the microscope. Do you understand this length of the tube of the microscope? So what are the things that you must remember? The length of the tube of the microscope is V naught plus UE. Do we see this? Yes or no? No or yes?
Yes, sir.
V
Yes,
naught
sir.
plus UE. Then the other terms, I'll give you 5 minutes to draw the diagram. Once you're drawn the diagram, I'll just give you the formulas. Okay? Draw the diagram. If there's
Okay, sir.
anything that you don't understand, what you have to understand is the final image that is there is virtual, erected, no, it's inverted, actual, with the actual image it is inverted and it is magnified. 5 minutes you have to write down, draw the diagram, please.
I will keep this. Completed, sir.
All of you are completed, bacha?
Yes, sir.
Okay. Okay. Then remember, whenever we are doing anything in a microscope, the next thing that we have to remember is to find out the magnifying power of this instrument. And the magnifying power of this instrument is MO multiplied by ME. MO standing for the magnifying power of the objective and ME standing for the magnifying power of the eyepiece. Do we understand this? Yes or no? No, yes.
Yes, sir.
I can write this as V naught by U naught. Magnifying power of a simple lens is V naught by U naught. And magnifying power of the eyepiece, we have already seen in a simple microscope, it is D by U. I'm writing it as D by UE. This is the formula that you have to remember. Again, we have to find the answer in case of two cases. The first case is when the image is formed at where? When the image is formed at infinity, then what will be the magnifying power? Tell me fatafat. V naught by U naught will remain like this. UE will become equal to FE, so you can write it as D by FE. Do we understand this, my dear friends? Yes or no?
Yes, sir.
Instead of V naught by U naught, I can also write it as F naught upon F naught plus U naught, the original formula of magnification of the lens, multiplied by D by FE. Instead of writing it as F naught upon F naught plus U naught, I can also write it as F naught minus V naught by F naught, multiplied by D by FE. Or if I don't want to write it in terms of this, I can say height of the first image divided by the height of the object into D by FE. Do we understand this, what I'm writing here?
Yes, sir.
Case number 2 will occur when image is formed. Where? At D. In that case, what will be the magnifying power, my dear friend? It will be V naught by U naught. That remains same. Instead of D by FE, my dear friends, I will have 1 plus D by FE. Do we understand this? You can write this in a different way.
Yes, sir.
Instead of V naught by U naught, you can write F naught upon F naught plus U naught, or F naught minus V naught by F naught, or HE by U. So you can write it here, yes or no? All these formulas. I'll give you 2 minutes to write this down. I hope you understand what we are doing, yes or no?
Yes, sir.
Please note it down, Vicha. Please let me know once you are done, Bacha.
Completed, sir.
So fast, so quick. Well done. What about the others?
Done, sir.
Everyone has done. Wow, we are moving so fast. I never thought so. Well done. Okay, so now that takes us to the last thing of this chapter, which is known as the astronomical telescope. Any idea what an astronomical telescope is? Yes, my dear friends, astronomical telescope. Astronomical telescope. What is an astronomical telescope is used for? Yes, bacha, tell me. What do we use an astronomical telescope for? Looking at distant object, looking at far off galaxies. Observing stars. That is correct, my dear friend. Again, this astronomical telescope. I'm showing you the diagram, and you will have to draw that diagram and remember some important things in that diagram. What are the important things that you have to remember? See, these rays, they are coming from infinity. Do we understand this, my dear friends? Very far off. So the first image, oops, wrong color. So the first image is formed here at the focus of the objective. Do we understand this?
Yes, sir.
Then this image acts as an object for the second lens, and it forms again a real, sorry, a virtual, enlarged and inverted image. You see these two angles, alpha and beta. The magnifying power of the astronomical telescope is given again by beta by alpha, and if I put proper values, it will be equal to minus f naught by ue. Do you see this diagram? Can you draw this diagram, beta? Do you want me to draw a more magnified one, a more bigger one, or can you draw it from here? F naught is the focal length of the objective, FE is the focal length of the eyepiece, VE is the distance of the final image from the eyepiece, UE is the distance of the first image from the eyepiece. Do we understand all these terms? Yes or no? Can you draw it?
Yes, sir.
Draw it. Yes, but have you done this? Now you're still drawing the diagram? Is it such a difficult diagram? Probably you are trying to draw all the three rays. You could have drawn just the two rays and you could have gotten the answer or drawn the diagram.
Completed, sir.
Okay.
Done, sir.
Everyone? Everyone got it, bacha? Okay. Shall I move ahead?
Yes, sir.
Yes, sir.
So then we have to see the magnifying power in two cases. What are the two cases, bacha? Tell me. Case A,
At infinity.
when image is at infinity, and in that case, oh, just forgot to tell you something. I'll take you back. Here in compound microscope, we have written the two formulae. Image is formed at infinity and image is formed at d. We have not written the length of the tube. Length of the tube in this case will be equal to V naught plus Fe, and in this case the length of the tube will be V naught plus UE in terms of absolute values. I've already shown you the tube. Yes or no, bacha? Yes or no,
Yes,
bacha?
sir.
Length of the tube. So just remember the formula for length of the tube as well for the microscope. In both the cases, in first case it is V naught plus Fe. In second case it is V naught plus the magnitude of UE. Why I'm writing magnitude? Because UE according to sign convention is negative. Okay, got it? Got it, bacha? Now let us, have you noted it down?
Yes, sir.
Okay. In this case, the magnifying power will become minus F naught and UE ki jagah we will have Fe. Do we understand this? And the length of the tube will be F naught plus Fe. F naught always comes here because the first image is always formed at F naught. I hope you are understanding this. Yes or no? No or yes?
Yes, sir.
Yes, sir.
When the final image is formed at D, which is the least distance of distinct region, in that case, the formula becomes minus F naught by Fe into 1 plus Fe by D. And in this case, the length of the tube becomes F naught plus UE. You can write it as magnitude because we are only going to use the magnitude and not the sign. I'll give you 2 minutes to note this down, bacha.
Completed, sir.
Completed, everyone? Bacha?
Yes, sir.
Okay, everyone is doing so great. I'm pretty impressed. So here we are understanding the different formula, and now I'm going to show you some important points, and most of the questions that are going to come in your exam will be from those points. The difference between a compound microscope and an astronomical telescope. This is where I suspect most of the question would be coming in your exam. So please note them down very carefully. And the first thing about this is compound microscope. It is used to increase the visual angle of nearby tiny objects. Here it is used to increase the visual angle of distant object. We all know this. First, listen to me. Then you just note down whatever I'm highlighting. I'll give you time because that is it for today's class. Field lens is also known as objective lens. Objective and eyepiece both are convergent, convex lenses, short focal length, and they are short aperture. They are small lenses, small. Here, objective is of large focal length and aperture is bigger in size, while eyepiece of short focal length and aperture. Eyepiece is short, objective is large. You have seen the larger telescopes, they have this big lenses. The bigger the lens, the farther you can see. John Webb telescope and all those things. Okay, final image, inverted, virtual and enlarged, and it is at a distance d to infinity from the eye. Here again the final image is inverted, virtual and enlarged. So in this case both of them are same. This is the most important point that has come in the exam many times, and please remember this. Magnifying power does not change appreciably if objective and eyepiece are interchanged. If objective and eyepiece are interchanged, magnifying power does not change. Here the magnifying power becomes 1 by m square, because in case of compound microscope, both the lenses are of similar nature, similar focal length. Magnifying power does not change so much. But here in case of a telescopic astronomical telescope, objective is very large, eyepiece is very small. If I interchange the lenses, the magnifying power becomes 1 by m square. The next point is magnifying power can be increased by decreasing the focal length of both the lenses. Decrease the focal length of both the lens, you will have more magnifying power. Here it is increased by increasing the focal length of objective and decreasing the focal length of the eyepiece. Remember these points. 4 and 5 points are the most important points. 6 point is not in your course, but you can remember this. Resolving power, how much you can resolve the image, is increased by decreasing the wavelength. Here the resolving power is increased by increasing the aperture. It's not in your course resolving power, but I would hope that you can very nicely remember this point 4 and this point 5. Very important points, and I'll give you 5 minutes to note this down. Note this down very carefully. Questions are going to come from this. Have we noted down the point, bacha?
Sir, 1 minute.
Okay.
Completed, sir. Completed, sir.
Okay. Just a minute. Okay, then this is the difference between a compound microscope and an astronomical telescope. One of these points may come as a full-fledged question plus 4-mark question in your exam. With this, actually, we come to an end of this particular section of your course where we are done with your ray optics. We have covered everything starting from reflection, refraction, plane surfaces, curved surfaces, lenses, combination of lenses, everything that is possible, optical lenses, everything that was a part of your course has been covered, and I hope that you remember them. In the next class, we will start with the next topic, wave optics, and we'll try to finish it. It's a small topic. We'll try to finish it in what is today. Today is Wednesday, Thursday, Friday, Saturday. 3 days is my target to finish your wave optics as well, so that you are done with this, and then probably can move on to some other topics as well. So that's an end for today's class. We say goodbye to ray optics and we'll move on to wave optics. I'll see you in the next class. Be there in the class. And if there's any doubt, you can always come to me. Take care. Have a nice day. God bless you all. Bye bye. I can't see you.
Bye, sir. Take care, sir.
Take care.